A very good morning. My name is Eswerr. My number is 205080. As for the part A, how kNN is used for a classification task. First, what is kNN? kNN is a supervised machine learning algorithm used for both classification and regression tasks and is a non-parametric algorithm that makes prediction based on the similarity of instances in training data. So steps that use that the kNN used to use for the classification task is first is collect the data collection and pre-processing. First is collect the data. A label data consists of instances known as class labels. Each instance is represented by these features and is important to process the data, which involve handling missing values, normalizing features, and encoding categorical variables. Next is we need to choose the value of the k. We need to decide the value of the k, which determines the number of the neighbors to consider when making predictions. A small value of the k can lead to overfitting, while a large number of the value k can result in underfitting. The optimal value of the k is typically determined through estimation, or cross-validation. Third step is calculating the distance. For each new instance we want to classify, we need to calculate the distance in the training data set. Common distance matrices that are used in kNN is including Euclidean distance, or Manhattan distance. The choice of distance metric depends on the nature of the data lah. Next is selecting the nearest neighbor. Once the distance is calculated, need to select the nearest k value based on the shortest distance. These neighbors are the instances in the training data set that are most similar to the new instance we want to classify. Next is majority voting. The next step is to determine the majority value class label among the k nearest neighbors. This is done through a majority of voting scheme where each neighbor's class label contributes to the final prediction. So the class label can receive the highest number of the votes as assigned as a predicted class for a new instance. And lastly, we need to making the predictions. We need to assign the predicted class label to a new instance based on the majority voting result. So this process can be repeated for each new instance that we want to classify. That's how the kNN is used for a classification task. Next, we move on to the code. Okay, first we need to import the relevant libraries, which is pandas and numpy. Pandas used for the data, to read the data, and numpy is used for the numbers. Later on, we need to use the klearn, which is mostly for the machine learning. Okay, after that, we need to use this command to read the data set, which is a diabetes we're going to use in this code. And this length diabetes dataset is the calculating the length of the dataset. Then we need, if we want to see the the data of the dataset, we need to use this command diabetes underscore dataset dot head open bracket and close bracket, so we can see the dataset here lah, which is in the database diabetes dataset here lah. Okay, and this is another way to see the diabetes dataset as well. Okay, later is 0 not accepted. Okay, this one, some values cannot be 0. Okay, for example, here we can say as insulin. Insulin cannot be 0 for a human. So we can use this code, the 0 not accepted, and which attributes we cannot make it 0. For here, glucose, blood pressure, skin thickness, BMI, and insulin. So we use this code to make the non-zero accepted for these 5, and we use this command to replace the 0 with the average value of the data, so the value cannot be 0. Later on, we can check whether the value is still 0 or not, or whether it's updated or not. So we can type again the diabetes underscore data set. You can see the insulin value is not 0 again. It's already updated value, which is using the average of the data, which is okay lah. Later on, we need to use the data preprocessing, which is splitting the data set. Okay, first, we need to train the certain portion of the data and leave the rest for the testing. Okay, so here X is actually a feature, Y is actually a label. After that, we can use this command print length X to see the length of the X, and use print length Y, you can see the length of the Y. And then we use print X dot shape and print Y dot shape to see the dimension of the data, which is for the X, there's 768 and 8. For the Y, it's a 768, and just this one is blank, is actually a 1. Then if you want to see the just the label value, we can just use this command like Y test. You can see this, just see the Y value only, which is the label value only. Okay. To see the X test only, we can just use X test. You can see the X values only. Okay. Later, after that, we use the feature scaling, which is feature extraction, which is feature scaling. So why do we need to standardize why we're using the X equals to standard scalar is we need to standardize the value in dataset, because each of the value has a different ranges. So we need to standardize the value. So that's why we're using the standard scalar. So as you can see, we can see the X value, right? See X text. X text, you can see the values are already in the converted to the array, and we can see that it's normalized than before, all in same range, no differences. That's why we need to use standard scalar. Later on, we need to import the import mag and see the length of the X test. Okay. This is because we need to define the model, which is we need to decide setting the parameter of the k. To choose the parameter of the k, we need to use odd number. So here I use 11, and I use the metric is Euclidean. So we need to train the model, which is X train and Y train. After that, we need to predict the test result to predict the Y predict, which is based on the X test. So the length of the Y prediction is 154. And you want to see the Y prediction punya value, Y predictions value, you can see it's already in the array, which is consists of 1 and 0 only. It is already predicted. Later, we need to evaluate the model. So for that, we're using CM equals to confusion matrix, which is taking the input based on the Y test and Y predict. So you can see here it's 94, 13, 15, 32. 94 is actually the TP, 13 is actually FN, 15 is actually FP, and 32 is TN. So you can, if you want to see the score, you can use the command like print F1 underscore score, Y test and Y predict. You can see the 0.16. That's the score of this thing. And we can just also can see the accuracy of the score, which is 0.8181, so and so on. So we can just take the first 2 decimal or 3 decimal point lah. So the only thing we can conclude from here is the accuracy score is actually 81%, which is 81% of prediction is correct. So that's the explanation for the code we use for the diabetes data set. That's all. Thank you.